Hello, I welcome you all. The problem reads determine the acceleration of the blocks when the system is released. The coefficient of kinetic friction is nu k and the mass of each block is m. So they have the same mass m. Neglect the mass of the pulleys and the cord. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Benam. So first things first, of course, we use kinematics to relate acceleration in the two cables. B and A or A and B, and later on use static equilibrium for the tension. Later on use the equations of motion. So let's use kinematics now to relate the position, later velocity, and acceleration. So we have two sides. Let's call this our B. We call this our A. Okay. So this is B. This is SB. This is SB. And this is SA. Right. So let's say our SA plus SB is equal to L. Therefore, derivative with respect to time VA plus VB is going to be equal to 0. L is a constant. This we left it out because it's the same throughout. And then we do have, let me write this plus, it's not very clear, like so. Then our AA plus AB is just equal to 0 as well. Therefore, AA is just equal to minus AB. So found this part. Let's do a section. We do a section there, we do a section there. The tension in the cables will be like so. So we'll have tension like so. Tension like so, which will be the same throughout there. We are assuming no friction between the cable and the pulley, like so. So this is T, this is T, this is T, this is T. All right. Then what else do we have? We do have the weight. Okay. We do have the weight, and then this block B tends to move to the left. Therefore, our friction will be in this direction like this, and we have the normal force. Okay, so this is NB and this is FK. This is WB, which is just equal to MBG, and this is WA, which is equal to MAG. Then we are going to choose our kinetic to be in the same direction. Again, this is one of the ways to solve this. Not the only way, just one of the ways. If you don't want to use this, you can use another method. The reason we are using this is just to ensure that the signs, we assume the same direction, so that when we begin to solve the equations simultaneously, we can use them with ease. Okay, like I said, this is one of the methods and not the only one. So there we go. So we have in that direction like so. Okay, and this is MA as well. So we have assumed the same direction. So what we need to do is let's start with our block A. Okay, so in that direction we are saying we have WA minus T equal to This is the summation of forces in the y. Okay, this is summation of forces in the y. So let me write this. So we have summation of forces in the y equal to MAY going down in our reference. So we have WA minus T equal to MA. Therefore, this is just MA G minus T equal to MA AA. Okay. So we have one equation. Let's go to block B. Block B, so we have summation of forces in the x equal to MAX going in this direction as our reference. Before we find this, we need to find, since there is friction here, let's start with y. So say summation of forces in the y equal to MAY going up here being our reference. Going up here being our reference. Okay. If you want, we can choose down, no big deal. So we'll have NA minus WB equal to 0 because our AY is equal to 0. So this part becomes 0. Okay. Therefore, our NA is just going to be equal to WB, which is just equal to MBG. Then we have summation of forces in the x equal to MAX going in this direction being our reference. So we have here Fk is equal to mu k is equal to mu kn. So we have Fk minus T equal to MAB. Okay, so this is MBAB. Therefore, we are going to have mu k. Our NB, this is NB. Okay, how was I writing this? Sorry about that. I meant B. Okay. So our B there is just MBG minus T equal to MBAB. Alright. So once we've done so, we need to solve these equations simultaneously. So we do have this A equal to minus AB, and then we do have, let's use one of the equations there. Let's say this one, MA G minus T equal to, this is one of the equations, MAAA. Okay, this equation here. Alright, for block A. So what we'll do is we are going to fit this there, and once we do so, then we are going to have the following equation: MAG minus T equal to minus MAAB. And we'll correct this equation also, which is just mu k MB G minus T equal to MB AB. So we are going to solve these equations simultaneously. I'm going to use the substitution method, subtracting, so that I just get rid of t. Of course, they're asking us to find the acceleration. So this just becomes mag minus mu k mbg equal to minus ma ab, okay, minus mb ab. Alright, so let's make AB subject to the formula. So AB here will just be equal to, there's a minus there, we can factor it out, which you can bring this side. So this just becomes minus. Let's factor out the G. Okay, then we'll have MA minus mu K MB. And then there we go. Then divided by MA plus MB. So this is the equation minus. Initially we had chosen this to go the other side, so this minus just indicates that this AB is supposed to be going in. But given that we have been told that, given that MA is equal to MB, this is a general equation that I just gave you here, where MA is different from MB. But in an event that this is equal, okay, therefore our AB just becomes equal to minus, we can factor M, and M is the same, so we can factor out mg like so. Then we remain with 1 inside, then mu k, okay, then divided by 2m, right? Does it make sense? Okay, this one was a general equation. Then we have now a more specific one. Then once we cancel out this and this, then we have AB is equal to G divided by 2, then 1 minus mu k. Okay, there's a minus which I just need to show. There's a minus like so. And another way of writing this is AB is just going this side. Okay, that's what the minus means. Okay, so this is just equal to G divided by 2. Then we have 1 minus mu k. Alright. And if this is the case, therefore AA, okay, our AA will not have any minus, it will just be positive. AA is just going to be equal to G divided by 2, 1 minus mu k. And the direction for this is just going down like so. Right, so let's also solve t if you want to. We can work out the t. What's the value of t there? So if we are to replace the t, replace AA in here, this equation. So let's solve for t. Here, let me create a little bit of space here. Create a little bit of space here like so. Okay. Alright, so let's solve for t. Again, it's not part of the problem. Let's get one of the equations. Let's get this one. Alright. So if you go to that equation, given that MA is equal to MB is equal to M, then this equation MA G minus T equal to MA AA just becomes, this one just becomes, it goes the other side, So this one just becomes M. This just becomes T. T is equal to, this T goes there, this comes this. T is equal to M. We factor out M. Alright, then we'll have G minus AA. Right? Alright, so we have AA in there. Let's replace AA. We know that our AA, this is our AA going down. We calculated this coming from this. This is equal to G divided by 2, then 1 minus mu K. Okay, then let's plug this here. Alright, and when we do so, then we are going to have T is just equal to, T is equal to M. Then we have G minus G divided by 2, okay, minus G mu K divided by 2. Okay, and therefore our T just becomes equal to mg divided by 2. Then this part just becomes 1. Then the d minus by minus just becomes plus mu K. So this is a constant, and this is really about it. So we have found AB, okay, and AA, and these have the same magnitudes, okay. And we also decided to just find T, which is also the same. Alright, so I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.